welcome to the chemistry tutorial for today, and enjoy the bit of the lesson as we proceed. So, our topic for discussion today is the moles. The subtopic is introduction to the moles. The date is that the lesson is recorded on 31st of July 2020. At the end of this lesson, the learners should achieve the following objectives. They should be able to define the term mole. They should be able to calculate moles, mass, and molar mass. They should also be able to calculate the number of atoms using the Avogadro's constant. The lesson is prepared and presented by Teacher Stephen of St. Kevin Nyali Elite High School. We would like to encourage you, because we usually upload the tutorial video for the chemistry and mathematics into this YouTube. So I would cajole you to subscribe onto our YouTube channel and click the notification button. That if you do so, you will be notified once we upload a new video into the channel. Otherwise, I wish you well as you enjoy this lesson until the end of it. Thank you and welcome. So the Brilliant Education Publishers is a registered company that currently offers the online exams. The exams are done online, they are submitted online, and the student will be able to view the score at the end of his or her submission. Also, Shiori will be able to see the missed question against the correct response or responses. The exams are done every Saturday and Sunday of the week. For that means the Adventists can now do the exams on Sunday or after the Sabbath. Also, those who goes to church on Sunday also can do the exams on Saturday. The registration is for this week is ongoing. Whoever wish to register with us, you can only pay the amount according to your level. So we have the preschool, that is CBC. The CBC, we only offer grade 3 and grade 4. So this week, the grade 4 will be able to do mathematics and English activities, and the charge for grade 4 is 45 shillings for all those subjects offered this week. Also, we have the primary. Primary we offers only from standard 5 to standard 8. This week they will be having mathematics and social studies, and the charge for those two subjects is only 55 shillings. And also we have the high school. The high school we only offers from Form 1, Form 4, and the charges this week they have mathematics and English. So whoever wish to register for the high school, it is only 40 bob for the two subjects offered this week, and the top 3 per subject will be awarded monetary value, and also they will be able to, all the participants or all the contestants also will be awarded the certificate of participation, where we'll be able to send to you via WhatsApp. The certificate is stamped by Brilliant Rubber Stamp, and you will be able to, we advise you to go to any cyber so that they can print them for you on the certificate paper, so that this will help you at least to uh, to show an evidence that you once sat for the online exams during this pandemic. All the registration fee should be sent direct to our till number, that is 51 77 589, and the M-Pesa transaction message should be sent to the CEO of the Brilliant through the number 07 11 41 05 83. 07 11 41 05 83. Also, you can download thousands of learning materials for primary and secondary from our website. Just click www.co. Sorry, it is www.brillianteducationspublishers.co.ke, and you'll be able to register on our website and you download anything that you might be in need of so that it can catalyze your revision during these hard times. Otherwise, thank you, and let's proceed with our lesson. So first of all, we are going to begin with the moles. So the mole, uh, forget about the mole of animal that maybe, you know, now this we are going to deal with the mole, which is an SI unit of amount of substance. So a mole is a amount of substance or amount of substances. So there are some number of particles which are measured in terms of moles. For example, we have atoms. Atoms are measured in terms of moles. Ions also measured in terms of moles. Molecules are also measured in terms of moles. Electrons are also measured in terms of moles. We have cows, we have cars. All those one are measured in terms of moles. The mole of a particles is the number of particles, that is the number of particles in one mole is always referred to as Avogadro's constant. And the Avogadro's constant is denoted or represented by letter capital L. So the amount or the number of particles in one mole is referred to as Avogadro's constant. To mean it does not vary. It has a constant number of particles. So to mean one mole of a substance, one mole of a substance has a fixed number of particles. So we should be able to know this, that moles, one mole of a substance has a fixed number of particles, which is now called the the Avogadro's constant. So the constant of Avogadro. So, for example, what you have to know, the Avogadro's constant contains it contains 6.023 times 10 raised power 23 particles. So one mole of any substance contains the Avogadro's constant or the Avogadro's particles, or it contains the particles which is 6.023 times 10 raised power 23. So you should be able to know that. So one mole is equivalent to 6.023 times 10 raised power 23, which is now equal to this one. So if one mole contains 6.23 times 10 raised power 23 particles, so what about 2 moles? So for you to know the particles which are there in 2 moles, what you will be able to do, you will multiply 2 times the number of particles in 1 mole. That is 2 times 6.023 times 10 raised power 23, which if you do it correctly, you'll be able to get 1.205 times 10 raised power 24. So if so long as we know the number of particles in 1 mole, we can now be able to calculate the number of particles in any given moles. What you do, you just multiply a given moles or a given mole times the number of particles in 1 mole, which is 6.023 times 10 raised power 23. For instance, we are asked, if you're asked to calculate the number of particles in 0.0025 moles, what you will do, you will just multiply 0.0025 moles, you multiply by 6.023 times 10 raised power 23, which if you do it correctly, you'll be able to get this one, which is 3.914 times 10 raised power 21. That is very, very magnetic. So let us proceed. If we come again to this, now the number of 1 mole, the mass of 1 mole, the mass of 1 mole of a substance is now called the molar mass. So the molar mass is the mass of 1 mole. And also the mass of the molar mass are equal to the relative atomic mass of an element is also equal to the relative molecular mass of the molecules, also is equal to the relative formula mass of a compound. So you should be able to know this one as we proceed on, and kindly follow it very carefully. If you do so, you won't be having any problem in doing any calculation under the moles, and also uh, calculating the number of atoms in a given mole or given moles. So let us go one the step by step. So the first one, we are going to deal with the element, and in Form 1, you discussed or you defined what is meant by the term an element, of which there I'm very sure you know what is meant by the term element. So an element has a mass equal to relative atomic mass, which is now RAM in grams of the element. So to mean, when we are talking about an element, we usually talk about the relative atomic mass. For example, we have been given the molar mass of carbon, which is equivalent to its relative atomic mass, which is 12. So the relative atomic mass of carbon is 12. And where the students always get confused, they get confused between relative atomic mass and the atomic number. So the atomic number of an element is totally different to its relative atomic mass. We know that atomic number is equivalent to the number of protons in that element or in that atom. So you should not confuse yourself with these two terms, that is relative atomic mass and the atomic number. So the relative atomic mass is just equal to the molar mass of that element. Like the molar mass of carbon is 12, and which is equivalent or equal to relative atomic mass of carbon. So that carbon has got number of particles. If carbon uh, is equal to gives us the 1 mole under its relative atomic mass, which is 12, then the number of particles present in it will be now this one, which is which is 6.023 times 10 raised power 23. So also we have this one, which is the molar mass of sodium. The molar mass of sodium is equivalent to its relative atomic mass, and the relative atomic mass of sodium is 23. You should be able to draw that. And its atomic number is 11, or the number of protons, or the number of electrons of sodium is also equal to 11, but its relative atomic mass is 23. But don't be worried, all this we will be given in an exam, so there is no need of worrying about uh, the same. So you should not worry about that. So if 23 grams of sodium contain 1 mole, to mean the number of particles in sodium will be now 6.023 times 10 raised power 23. Let's see the next. The next, now, if you check this, the molar mass of iron is equal to the relative atomic mass, which is 56. So if the 56 gram of an iron gives us 1 mole, then the number of particles in that iron will be 6.023 times 2 raised power times 10 raised power 23. So that is that. You should be able to know that. So the second one is now a molecule. A molecule has mass equal to relative molecular mass. So when we are talking about the molecules, we will not be talking about the relative atomic mass, but we will be talking about the relative molecular mass, RMM, in grams. So how do we get the relative molecular mass? The relative molecular mass is gotten by adding the relative atomic mass of the element making that molecule. Kindly make sure you understand that how we get the relative molecular mass. It is gotten by adding or summing, or you sum the relative atomic mass of the elements making up that molecule. Tafadhali, you should know that. So, and we know that the number of atoms making a molecule is now called atomicity. So the atomicity are now the number of atoms making up a molecule. And most of the gaseous molecules are diatomic. Diatomic means they have two atoms. Like if you check the oxygen gas has two oxygen atoms. If you check this one also, chlorine, 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 or no, not chlorine, but hydrogen gas. Hydrogen gas is also have all is also having the two atoms of hydrogen. Nitrogen the same, fluorine the same, chlorine the same, bromine the same, and iodine the same. So they are called diatomic. Di means two from the first three letters. This one means di, which means two. Also, we have the noble gases, which are now found in the group 8 of the periodic table. So in Form 2, you learned that the group 8 elements are referred to as monoatomic. Monoatomic to means they have one atom. Mono from the first four words, or the first four letters forms mono, which means one. Just the way you sometimes call the form one a mono means one. Uh, e.g., we have helium, argon, neon, and xenon. I should be able to know that. Then we have the ozone gas. The ozone gas has now three atoms of oxygen, which is now giving us triatomic. Tri means three. Tri means three. So we have we have mono means one, di means two, we have tri means three, and also we have tetra, which means four. Otherwise, let us proceed. So how do we get now the molecule of no the molecular mass, the relative molecular mass of oxygen? We said that for us to get the relative molecular mass of a molecule, we add the relative atomic mass of each element, making the molecule. For example, oxygen as an element has the relative atomic mass of 16. So 16, you multiply by 2, you'll be able to get 32. So to mean the oxygen atom, the oxygen a molecule, I mean the oxygen as a molecule has a relative molecular mass of 36. We can check on the next slide. So here, the molecular mass of oxygen, the molar mass, I mean the molar mass, which is equivalent to relative molecular mass. So here we'll get that the molar mass of oxygen, because oxygen is now diatomic, is equal to 16 multiplied by 2. Why? Because oxygen atom, the oxygen as a molecule has two atoms. So if you multiply and and one atom of oxygen has a relative atomic mass of 16. So if you multiply 16, that is 16 multiplied by 2, you'll be able to get 32 grams. So the relative molecular mass of oxygen will be now 36. So to mean if 36 is equivalent to 1 mole, then the number of element present in oxygen molecule is now 6.023 times 10 raised to power 23. Also, we have the chlorine, the molecular mass of the chlorine. The molecular mass of the chlorine. Chlorine has two atoms of has two chlorine atoms. The chlorine molecule has two chlorine atoms, and one chlorine atom has got the relative atomic mass of 35.5. Is having that 35.5. So if there are two, you multiply this by 2. So if you multiply 35.5 multiply by 2, you'll be able to get 71.0 grams. So if 71.0 grams of chlorine molecule is equivalent to 1 mole, then the number of particles which are present in chlorine molecule will be just 6.023 times 10 raised power 23. Also, we have the molar mass of the nitrogen. We just do the same as we have done. That there is no difference in doing that. So let us see this one, a compound. So a compound has mass equal to the relative formula mass. So when we come to compound, we talk about the relative formula mass, which is RFM. And what should be able to know, we have so many types of compound. We have so many compounds. We have sodium chloride. We have sodium hydrogen carbonate. We have calcium oxide. We have so is a compound is made up of two or more elements combined together. So, for example, if we have water, water is an example of a compound of hydrogen and oxygen. and you can see how to get the molar mass or the relative formula mass of water. Water has water has two elements combined together. So, for example, if we check this one, if we check here, if we check this side, you will realize that hydrogen has one atomic, the relative atomic mass. So if you add it to that, here there are two. You multiply 1 times 2, you'll be able to get 2. And also oxygen has a relative atomic mass of 16. So if you add 2 plus 16, you'll be able to get 18. So water has a relative formula mass of 18. So if it is like that, and if that water contains 1 mole, then it will be equivalent to it will contain, or it contains particles of 6.023 times 10 raised power 23, where water will now contain 2 times the number of particles in 1 mole. Then you will be able to get the particle of hydrogen atoms. Oxygen, the same, multiply, you will be able to get the number of oxygen atom in water, is in a compound of is in water compound. So that is that. So let's see this. So we have also the sulfuric acid, the molar mass of sulfuric acid, which is this. So what you'll do, you will add. How do we get the relative formula mass? It is by adding the relative atomic mass of all elements making that compound. Like hydrogen, hydrogen has one relative atomic mass, and here there are two. So you multiply 1 times 2, where you will get 2. And also we have sulfur. Sulfur has a relative atomic mass of 32. And also we have oxygen, and here there are 4 oxygen atoms, but one oxygen atom has a relative atomic mass of 16. So 16 you multiply by 4, you'll be able to get 64. So if you add all of them, you'll get, that is 2 plus 32 plus uh, 64, you'll be able to get 98. So just the way we have said, if you add their particles, you'll be able to get the number of particles in a given moles of that sulfuric acid, of which we are going to discuss later. We have also a compound of sodium carbonate. So sodium carbonate, you'll just do the same here. We have 2 sodium atoms, but one sodium atom has got 23 relative atomic mass. So if you multiply by 2, you get 46. You add to the relative atomic mass of carbon, which is 12. Then also you add to the 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 relative atomic mass of 2 oxygen atoms, where one oxygen atom has a relative atomic mass of 16. So 16 multiplied by 3, you get 48. So 48, if you add all of them, you'll be able to get 106 grams. So from there, you'll be able just to calculate the number of particles in that compound, where we will discuss later. So also, if you come to this, now we are now coming to the calculation in chemistry, calculation involving moles. So to calculate the number of moles in solid, we use the following molecular triangle, where this one is mass, that is mass. Then This is now molar mass. This is moles. This is moles. Then this is molar mass. So to mean mass is equal to molar mass times moles. That is molar mass times moles. Then also moles will be now equal to mass over the molar mass. Molar mass will be equivalent to mass over the over the moles. So that is how you should be able to know it. Then also to calculate the number of moles in solubility, we use the following triangle where n is the number of moles. So the number of moles is now equivalent to concentration times the volume in liter. The concentration in moles per liter or the concentration in grams per liter over the mass, something like that, or moles can be calculated as the concentration per liter, moles concentration in moles per liter over the volume in liter. So in this one, you should be able to master it because it will help you when you reach in the concentration and the molarity. So we have the practice. First, here we are told to calculate the number of moles present in zero point 0.2 grams of sodium. So here we have been given uh, the mass of sodium. So, and how do we calculate moles? We said moles, that is moles is equal to a mass is equal to mass of molar mass. So that is what we said. And if you come here, let me, if you come here, you realize that we have said moles is equal to molar mass. No, is equal to mass, maybe in grams over the molar mass. And the mass of sodium atoms were given to be 0.23. And now the relative atomic mass of sodium is 23, and relative atomic mass of sodium is equivalent to the molar mass of sodium. So when you divide 0.23 grams divide by 23, you'll be able to get 0.01 moles. So that is the number of moles in zero point 0.2 grams of sodium atoms. So what you should know, this is the most important here. You should be able to know this one. That moles is equal to mass in grams over the molar mass. And from here, this is the main. So from here, you can now even calculate. Maybe if you ask moles mass, you can be able to you just do cross multiplication, where mass is equal to moles times molar mass. Though we're not talking about that. So I was just explaining to you how you can make some calculation out of this formula. So, but if you have mastered the triangle one, where it is written like this, we have discussed it in the previous slide, where this is the molar mass or moles. Let's this to be moles. Then this is molar mass. Then this is mass. So mass is equal to molar mass the over the moles. Now mass is equal to molar mass times moles. Mass is equal to molar mass times moles. then moles is equal to mass over molar mass. Then or molar mass is equal to mass over the moles. So again, you calculate the number of moles in 0.23 grams of chlorine atoms. Chlorine atoms, not chlorine molecule. So chlorine atom. So we know that moles is calculated as mass in grams over the molar mass, and the mass of the chlorine atoms is 0.23. Then you divide with the relative atomic mass of chlorine, which is 35.5. So if you divide that, you'll be able to get 0.0065 moles. So from there, you'll be able to calculate that. Again, we have, you calculate the number of moles of 0.23 grams of chlorine molecules. So here is now chlorine molecules. So molecule means it is now diatomic. So the molar mass of the chlorine, one, the the molar mass of the chlorine atom is 35, and now here a molecule is made up of two chlorine atoms. So you multiply by these two that you are seeing here. So if you multiply, you will get 71. So now moles is equal to mass in grams over molar mass, and mass of the chlorine molecule is 0.23 grams divided by 71, which is the molar mass, to give you 0.0032 moles. So from there, you shall have calculated the moles of chlorine atoms. Calculate the moles in 0.23 grams of dilute sulfuric acid. So from here, first of all, what you first do, you must know the formula for calculating moles, where it is mass in grams over the molar mass. So, and you ask yourself, are you been given mass? Yes. Are you been given molar mass? Yes, you can calculate from the compound, where you had the relative atomic mass of hydrogen, or the relative it is the relative atomic mass of the chlorine atoms, where one chlorine atom has two relative atomic mass. So you multiply that by 2 by 1, you will be able to get 2. Then you add to the sulfur, which is 32, plus 4 times 16. So here it should be 4 times 16, not 4 times 14. It should be 4 times 15, 16, I mean, which will give you 64. So from there, if you add them, you will get 98. So the 98 is the molar mass. So if you divide 0.23 by 98, you'll be able to get 0.0023 moles of sulfuric acid. So this is the number of moles in this mass of sulfuric acid. So here is where I want you to be very keen. So here you calculate the number of atoms present, one in this one, dilute sulfuric acid, using the Avogadro's constant, which you have been given to be this one. So from here, we said earlier that one mole contain or is equal to a particle of 6.023 times 10 raised to power 23 times 10 raised to power 23. So for you to get now the number of particles which are present, or the number of atoms which are present in 0.23 grams of dilute sulfuric acid, you must calculate the moles. of that sulfuric acid, where we say that moles is given by mass over the molar mass. So the mass of sulfuric acid is 0.23. Then you divide by 98. You'll be able to get 0.0023 more moles. So this one, if one is equivalent to this, now this will be equivalent to what? Where you will cross multiply. So for us to get the atoms in this moles of sulfuric acid, we only multiply this times 10 raised power times 6.0 times 10 raised power 23. You will be able to get the number of atoms present in that sulfuric acid, which is now 1.38 times 10 raised power 21. You can also check this. That is another one is 0. You calculate the number of atoms present in 0.23 grams of solution of carbonate. Dehydrated. Dehydrated means there is no water of crystallization. No, sorry, not dehydrated. It is 0.23 grams of sodium carbonate dehydrate. To mean it is hydrated from this word. Deca means 10. So it has 10 moles of water. It has 10 moles of water. So this is the chemical formula for that uh, sodium carbonate 4 decahydrate. Deca means 10. Hydrate means there is water over crystallization. So it has 10 moles of water of crystallization plus this sodium carbonate. So from here, first of all, for us to get the number of particles here in this, or the number of atoms which are present here, what you do first, you have to calculate the moles of this. Where we said that the moles is equal to molar mass, no, mass over molar mass. Sorry, the moles is equivalent to mass in grams over molar mass. So let us get the molar mass of sodium carbonate dehydrate. Sodium is 23, and here there are 2. You multiply 2 times 23. Carbon is 12. Then oxygen, they are 3. Then 1, the atomic mass, the relative atomic mass of oxygen is 16, and that 3 you multiply 3 times 16. Then you add to the relative molecular mass of water. And here know that they have 10 moles already. Water has 10 moles. So what you do, you add you get the relative molecular mass of water, which is 18, then you multiply by this 10. You'll be able to get it all, which is now 276. So you'll have, first of all, here you will have 46 plus, sorry, let me use this one, plus 12 plus 3 times 16 is 48, then plus 18 times 10 is 180. So if you add this 46 plus 12, you'll get 58. 58 plus 48, we'll get 100 and 116. 180 plus 116 will get 276. So this is now the molar mass. So and the mass is this. So the moles is this one. The moles is 0.00083 moles. After that, you know that one mole has this number of atoms. So what about 0.0083 moles? You cross multiply, where you will multiply just like that, and you will be able to get 4.98 times 10 raised power 20 atoms. So that is the end of our lesson, and may God bless you. Subscribe to our YouTube channel. We'll be continue this lesson until the end of it. Any question at the end of this topic, I'll be able to post very good question, the topical question on the moles plus their marking schemes. So we'll work first is when we send the marking scheme and revise them together. Otherwise, stay safe. Subscribe to our YouTube channel. Follow us on Instagram. Follow us on Facebook. That is Brilliant Education Publishers. Uh, in Instagram, you can also follow us. That is Brilliant Education Publishers. And God will bless you, and also do our weekly exams, which will make you to feel as you are, as if you are in school continuing with the learning. Will keep you updated whenever possible. Thank you and be blessed.